Hello students, so today we will discuss about water and its properties and some information. So we know that the molecular formula of water is H2O. It contains two hydrogen and one oxygen. So it is compound of hydrogen. So shape of water molecule is bent shape. One oxygen is combined or attached with two different hydrogen and it forms angle. It is not a straight molecule. So our simple conclusion or simple observation should be it should be straight molecule, something like this, because we have only two atoms attached with oxygen. So maximum distance between them will be obtained when we have 180-degree angle. So it should be straight molecule, but instead it is a bent shaped molecule. So what is the reason behind it and why it gives this type of bent shape? So let's talk about it. Shape of water molecule is already discussed in earlier units, but let's talk about it anyway. So if we check the electronic configuration of oxygen, so it has 8 electrons because it's number 8. So electronic configuration of oxygen is 1s2, 2s2, 2p4. It has 8 electrons. So in outermost orbital, that means in second number orbit, it contains total 6 electrons. So it requires only 2 electrons to gain noble gas like electronic configuration. So that's why it combines with 2 hydrogen. So each hydrogen provides 1 electrons for sharing to complete oxygen's octet, and you will get H2O molecule. Now as we can see, we have two non-bonding electron pairs. We can represent them with N, and we have two sigma bond pairs. So total 4 electron pairs are present around the oxygen. And if we check the hybridization, then as we know, in hybridization we have to count non-bonding electron pair and sigma bond pair, and pi bond pairs are not included. So we have to count these two electron pairs. So we have one non-bonding electron pair in s orbital, we have one non-bonding electron pair in p orbital, and we have two sigma bond pairs, so total 3 p orbital. So hybridization will be sp3. That means around the oxygen we have 4 electron pairs arranged in tetrahedral manner. So let's say we have two electron pairs present here and here. These electron pairs are in plane of screen, and two electron pairs will be behind the screen and above the screen. Behind the screen pair can be represented with dotted line like this. So we have one electron pair behind the screen and one electron pair is above the screen. We can represent it with solid line. So these are the 4 electron pairs around the oxygen. So out of 4, as we can see, as we know, 2 are non-bonding electron pair. So let's say these one and these two are non-bonding electron pair, so none of the elements will combine there. And these two are sigma bond pair, so hydrogen will combine there. So that's why, because of repulsion of two non-bonding electron pair, water molecule gives us bent shape. Now if we compare water molecule with other group members of oxygen, that means oxygen is in group number 16. So let's compare it, H2O with H2S. So H2S has gaseous physical state, whereas H2O is in liquid state. Although all the group 16 members gives us same type of configuration with hydrogen, that means all of them will give us H2O type molecular formula, and all of them are sp3 hybridized, and all of them are band shape molecule. But still only H2O is in liquid state, whereas all the other members gives us gaseous molecule. So reason behind that is when hydrogen and oxygen combines with each other, hydrogen becomes partially positive, oxygen becomes partially negative. So when same type of molecule come close to this previous molecule, so positively charged hydrogen will feel attraction towards the negatively charged oxygen, and this is called intermolecular attraction. When two different molecules attracts each other, it is known as intermolecular attraction. So if we compare the intermolecular attraction strength of water molecule with H2S, that means in case of H2S, we have similar partially positive hydrogen and similarly partially negative sulfur. So when other H2S molecule come close to first molecule, then they also produce intermolecular attraction. But this type of intermolecular attraction is dipole-dipole interaction, whereas intermolecular attraction in water molecule is hydrogen bond. So hydrogen bond is strongest intermolecular attraction. That's why two water molecules usually come close together strongly, and that's why they are in liquid state. Whereas in case of H2S, they have comparatively weak attraction towards each other because they have dipole-dipole type of intermolecular attraction, which is weaker than hydrogen bonding, and that's why they will remain in gas state, whereas water molecule will be present in liquid state. Now let's talk about the solid state of water, that means ice. In ice, you can see this type of three-dimensional grid shape formula. Now usually when liquid becomes solid, its size shrinks or its volume decreases, and when it changes from solid to liquid, it expands. As for example, if we take example of metals, then usually heated metals have more volume than the cold metals. But in case of water, it is opposite. When liquid to solid transformation occurs in water, volume increases. That means liquid water has less volume than the solid water. Or understand it like this way, if you have 100 grams of liquid water, then volume of this liquid water will be 100 milliliters. But if you have ice, that means solid water, then 100 gram will be more than 100 ml. That means let's say it is 105 ml. So similar mass of liquid water and solid water or ice should have different type of volumes. Solid occupies more volume than liquid water, and this is the reason why ice cubes float on the surface of water, because they have comparatively less density. And reason for expansion is mentioned in this three-dimensional arrangement. As we can see, we have large voids or empty space present in solid ice, and because of this empty space, volume expands. So let's discuss about this figure. So green dots represents oxygen and orange dot represents hydrogens. So each oxygen atom is surrounded by 4 hydrogen atoms. Now out of 4, 2 hydrogen atoms are permanently bonded or sigma bonded with oxygen, and 2 hydrogens are attracted towards the oxygen in intermolecular attraction or hydrogen bondings. So permanent bondings will be mentioned as straight line, which can be seen here, and all the hydrogen bonded bonds are mentioned with dotted lines, which can be seen here or in multiple other parts. So as we discussed earlier, oxygen has 4 electron pairs around it. 2 of them are bond pairs, and let's say these bond pairs are present in screen, and 2 of them are lone pairs. So lone pairs are present above and behind the screen like this. That means all of the 4 electron pairs are tetrahedrally arranged around the oxygen. So towards this lone pair or non-bonding electron pair, hydrogen of other oxygen molecules will feel attraction. That means one hydrogen will feel attraction here and second hydrogen will feel attraction here. So we can rewrite this structure as like this. 2 hydrogens are permanently bonded like this, and 2 of the hydrogens are attracted via hydrogen bondings towards the oxygen. So each oxygen is surrounded by total 4 hydrogens. 2 of them are sigma bonded and 2 of them are attracted towards the oxygen because of hydrogen bondings. And we can see it in this structure. Let's zoom in and then observe the structure. So let's talk about this oxygen. So as we can see, it has two permanent bondings with two hydrogens. One is here and second one is here. So these two hydrogens, hydrogen 1 and 2, they are permanently bonded with oxygen via sigma bondings. And oxygen has two hydrogen bondings with other hydrogens of other water molecules. One is mentioned here and one is mentioned here. So this oxygen is surrounded by four hydrogens, and that's why all of these four hydrogens present around the oxygen in tetrahedral manner, and that's why it gives us a diamond like shape or diamond like network solid. In diamond, we have carbon atoms, and all the carbon atoms are attached with four other carbon atoms in tetrahedral arrangement. So it is similar to this type of ice structure. But difference in carbon and ice is, in carbon all of the bond lengths are equal. In case of water molecule or ice, two of the permanently bonded hydrogens have comparatively shorter distance from the oxygen, and hydrogen bonded hydrogens have comparatively longer distance from the oxygen. Now let's talk about the chemical properties of water. So first of all, it is amphoteric in nature. That means it can act as acid and base. If you have more acidic compound than the water, then water will behave as base with that compound, and if you have more basic compound than the water, then water act as acid with that compound. Or in simple manner, we can say that pH of water is 7. So if you have any compound which has less than 7 pH, then it will act as acid with water, and if you have any compound which has more than 7 pH, then it will act as base with water. That means any compound which has pH from 0 to less than 7, it will act as acid with water, and any compound which has pH from more than 7 to 14 will act as base with water. That means with acid, water is base, and with base, water is acid. And examples are mentioned as follow. We have ammonia, which is basic by nature. With ammonia, water will behave as acid. So acid, common nature of acid is to donate hydrogen as a proton, that means H plus. So water will donate H plus, and common nature of base is to accept H plus. So NH3 will accept H plus. So if we remove H plus from H2O, left is OH minus, and when NH3 accepts H plus, you will get NH4 plus. So that means when we dissolve ammonia gas into water, you will get NH4OH, ammonium hydroxide. Similarly, with H2S, water will behave as base, and as mentioned, normal nature of base is to accept H plus. So H2S releases H plus and water will accept it. So when H2O accepts H plus, you will get H3O plus, and when H2S releases H plus, you will get HS minus. And in small quantity, water also gives us autoprotolysis or self-ionization. That means water will behave as acid and base itself. That means one of the water molecule will behave as acid and other molecule will behave as base. If you have 1 liter of water, then 10 raised to minus 7 moles of water will participate in this type of reaction. So as we can see here, we have two different water molecules. One of the water molecule will behave as acid, second molecule will behave as base. So acid donates H plus to the base. So when base accepts H plus, it will turn into H3O plus, and when acid donates H plus, it will turn into OH minus. Now second type of property, redox reaction involving water molecule. That means water molecules can participate in reduction as well as in oxidation depending on the other compounds. So as mentioned, with metals, water can turn into hydrogen. If we check the oxidation state of hydrogen and oxygen, then hydrogen is in +1 oxidation state, oxygen will be in -2 oxidation state. After the reaction, oxygen is still in -2 oxidation state, so it do not participate in reaction. but hydrogen was plus 1 and after reaction it turns into 0. So that means plus 1 to 0 it represents reduction. So with metals, or let's say with strong metals, water molecules participates in reduction reaction. Similarly, when water is oxidized to O2 during photosynthesis, it participates in oxidation. That means we have H2O, again hydrogen is in plus 1 oxidation state and oxygen is in minus 2 oxidation state. After reaction, all the hydrogen will remain in plus 1 oxidation state. But oxygen will convert into O2 molecules or dioxygen. That means in O2 molecule, oxidation state of oxygen is 0. That means minus 2 to 0. Oxidation state increases. That means it is oxidation reaction. And with fluorine it also oxidized. We already discussed this reaction in redox reaction. Now next, hydrolysis reaction. In hydrolysis reaction, water molecule will participate with some of the molecules as mentioned follows. So P4O10 with water molecule gives H3PO4 and SiCl2 with water molecule gives SiO2 and HCl. That means water molecule either combines completely with the compound or it will dissociate and it will give us replacement reaction or substitution reaction. Then last we have hydrates formation. So from aqueous solution many salts can be crystallized as hydrated salt. Hydrated salt, that means water molecule containing salts. And we have three different types in it. So first one is coordinate water. Now coordinate compounds have coordinate covalent bondings in it. In coordinate compound mainly we have two different parts. One is a metal atom or ion which accepts electron pairs, and second one electron pair donating molecule, ion or atoms. Now for that we need electronegative elements which usually have non-bonding electron pairs. As for example, in this case we have water molecule. In water molecule oxygen contains two non-bonding electron pairs, and if requirement occurs then oxygen can use it for bond formation. So in coordinate compounds, if we have this type of coordinate compounds as mentioned CrH2O6, then it represents 6 water molecules are donating electron pair in single chromium atom or ion. That means all of the 6 electron pairs will be accepted by chromium. So that's why when we have coordinate covalent bondings, all of them will be mentioned in square bracket. So all of the H2Os donates electron pairs. We have a dedicated unit about the coordinate complex compounds in standard 12, so we will learn about it in detail in next year. Then we have interstitial water. That means as mentioned in interstitial hydrides, when unwanted sites are occupied by unwanted atoms, it is called interstitial site. So actual site for actually it is not a site or location for that atom or molecule or ion, but still it occupies it. That's why it is called interstitial. So similar situation occurs here. In certain molecule we have large gaps or empty space or voids in it, and water molecules will be trapped in it. That's why it is called interstitial water molecules. And last we have hydrogen bonded water. As for example, when we dissolve copper sulfate into water, it turns into CuSO4 5H2O. Now out of 5H2O, 4 H2Os will behave as ligand. That means as we discussed earlier, we have metal and electron donating atom, ion or molecule. These atom, ion or molecules, they are referred as ligands which donates electron pair towards the metal. So 4 of them out of 5, 4 of the hydrogen water molecules will behave as ligands, and one of the H2O is attracted towards the metal, copper metal, and that's why it is present just because of hydrogen bonding. It do not have any kind of permanent bonding with this compound. That's why it is mentioned as hydrogen bonded water.